Phenol is an important precursor to a multitude of chemicals. It is used to synthesize many drugs, herbicides, as well as cosmetics. It can also be used to make plastics, bisphenol A being the most notable one. In this video, we'll be making phenol by decarboxylating salicylic acid. For this experiment, only one chemical is required, and I used 10 grams of salicylic acid. A 100 milliliter round bottom flask was charged with 10 grams of salicylic acid. And then some boiling stones were added. A short path distillation apparatus was then set up. You can likely use a regular distillation apparatus, but you'll just have to insulate it really well. The condenser was filled with hot water to make sure that none of the phenol froze inside of it. The apparatus was then insulated using cotton, and aluminum was used to hold the cotton in place. I moved the insulation a little so you can see the phenol condensing. I collected the fraction that boiled between 145 and 165 degrees Celsius. The reaction that is occurring is shown above. The reaction is quite simple, where salicylic acid is decarboxylated by heat to produce phenol and carbon dioxide. The phenol has a much lower boiling point than the salicylic acid, so it's distilled off. Once the temperature reached about 165 degrees Celsius, nothing came over into the collecting flask. What was left was a black tar refluxing in the distillation flask. After cooling, this is what the thick black tar looked like. The phenol in the collecting flask was then distilled again under vacuum at 40 millibars. The product that I collected was between 85 and 90 degrees Celsius. The portion between 30 degrees and 85 degrees contains a lot of water, so this was discarded for purity purposes. In theory, this part does not need to be done under vacuum, but you will need to do it at a much higher temperature if you don't. The phenol was then distilled again, but before this was done, the apparatus was dried and cleaned. The product in the collecting flask was distilled, and again the product boiling between 85 and 90 degrees Celsius was collected. The final yield of phenol was about 4 grams, which represents a percent yield of about 44%. When done on a larger scale, such as 20 grams and above, the percent yield will be much better, more likely around 70%. The largest loss was after the second distillation, where a lot of the phenol was left trapped in the distillation flask as well as the distillation apparatus.